Let's learn about integration by parts. It turns out that integration by parts undoes the product rule. I've got my formula here in pink. If I go ahead and add this integral v du to both sides, I get the integral of u dv plus the integral of v du is equal to u times v. Then I take the derivative throughout this equation, d dx on everybody, gives me my product rule. So my derivatives undo my integrals and I get u dv plus v du is equal to, there's the product rule, d dx of u times v. Let's go ahead and apply it to this example. In this example, inside my integral, you'll notice that I do have a product. I've got x times cosine of x. When I'm deciding how to break this into a u and a dv, I'm going to choose u to be whatever will get smaller as I take a derivative. So I'm going to let u be my x. Everything else then needs to be my dv. So I'm going to break everything in that integral into either u or dv. Notice how the dx is always going to come along with the dv. Now I've got my u and my dv assigned. U is equal to x and dv is that cosine x dx. Now in order to apply the formula, I'm also going to need du. So I'm going to take a derivative there, and I'm also going to need v, so I'm going to need the integral there. So I do need to apply d dx of u, and I need to take the integral of dv. Applying those, du is equal to dx, and I'm going to take the integral of dv. The integral of dv is going to give me v. The integral of cosine x is equal to sine x. So v is equal to the sine of x. So now I've got everything that I need and I'm ready to apply my formula. So taking my integral, I'm going to apply my formula starting with u times v. So the integral of x cosine x is equal to u, which is x, times v, which is the sine of x, minus the integral of v du. So I want an integral followed by my expression for v, which is the sine of x, and du was dx. So I've got a really nice integral to solve. There is a plus c floating around here. I'm just going to remember to write that in the end. So as I continue to finish this guy off, I can bring down the x sine x. That one is done. The integral of sine is negative cosine, so I get a negative cosine here, negative cosine of x. I'll put that plus c in because I'm done integrating, and I end up with x sine x. I'm subtracting that negative, so I get plus cosine of x plus a c. In this next one, the integral of x e to the 2x, I again want to define everything in my integral as either a u or a dv. I know that the dx is going to go along with the dv, so that one's already taken care of, but I do want to choose this x here to be u. Like the last one, if I take its derivative, it's going to get smaller and actually go away and make this much simpler. That leaves everything else, the e to the 2x and the dx, to be my dv. Let's go ahead and put those in our chart here. So I've got an x and an e to the 2x dx. So I know that I need to differentiate u to get to du, and I need to integrate dv to get to v, and that's going to give me everything else that I need. So du is equal to the derivative of x, which is dx, just like we saw in the last one. And then I'm going to integrate to come up with a v. So e to the 2x dx inside of this integral, whenever I integrate an exponential base e, I'm going to get that exponential base e back, but because I've got that 2x there, I end up with a divided by 2 as well. This works really well because we've got x to the first power. So I'm going to go ahead and use that shortcut. I get an e to the 2x. I get that one back, but divided by 2. You could also do a u substitution here, but this is equal to our v. I'm going to remember the plus c when I am finished with my integral. So integrating this, I can start to apply my formula. So I need u times v first. U is equal to x. V is equal to e to the 2x divided by 2 minus the integral of v du. V is e to the 2x divided by 2, and then du is equal to a dx. The first expression is all done. I'm going to write everybody over 2 there, and I'm going to bring this divided by 2 out. If I put a 1 there, this is actually a 1 times or a 1/2 times that e to the 2x. So I'm going to bring that out in front, 1/2 e to the 2x dx. And I'm going to integrate that one just as I had done up in my table. So I've got my x, e to the 2x divided by 2. I've got my minus 1/2. When I integrate e to the 2x, I'm going to get that e to the 2x back divided by a 2. So times e to the 2x divided by 2. And I'm going to remember that plus c. This gets me to our answer, x e to the 2x divided by 2. Multiplying these fractions through, 1 times e to the 2x is e to the 2x. 2 times 2 in the denominator is going to be a 4 plus a c. The next one, we're going to integrate ln, which works just a little bit differently than the ones that we've seen so far. In the others, we were looking at a product rule, and integration by parts is perfect because it undoes a product rule. But I don't really have a product rule here as far as the integrand. So instead, I need to rethink that product as being the natural log of x times dx. I know that dx needs to be part of that dv, so I'm going to let it be dv, and that leaves me with the natural log of x being u. So I've got my definitions here. U is the natural log of x, and then dv is equal to dx. I need to take a derivative to get to du and an integral to get to v. Taking the derivative of u is the derivative of the natural log of x. That's going to be a 1 over x, and I'm going to write in that dx as well. And now I need the integral of dv. So my integral is going to give me v. So v is the integral of dx. Not a very exciting integral. We'll take it, right? The integral of dx is equal to x. Now I'm ready to apply integration by parts to our integral. I'm going to start with that u times v. U is equal to the natural log of x. I'm going to put absolute value bars around that natural log now that I've brought it outside of my integral. Just want to be really certain that my domain is greater than 0. Absolute value takes care of that. And then I need to multiply this times my v. So this is going to be times an x on the outside of the natural log, minus the integral of v du. V is equal to x, and du is 1 over x dx. I can cancel these x's, and I'm really left with right here 1 times dx, or just the integral of dx. I'm going to bring that x out in front of the natural log so it doesn't get lost inside of the ln. So I get x natural log of x minus the integral of dx. The integral of dx is equal to x, and then I need my plus c. I hope this was helpful. You guys are doing great. Take a look at this next video, and thanks so much for watching.